Okay, for this video, I'll be going through combined science, electric charge and current of electricity tutorial. Okay, so question 1, two balloons X and Y are suspended by insulating threads. They are held near a negatively charged balloon. Okay, so this is a negatively charged balloon. Okay, whereas this is balloon X. And in the next diagram, we also have the same negatively charged balloon. But this time we have balloon Y, and the concept that we need to apply here is that like charges repel and unlike charges attract. Okay, so it is quite obvious that for balloon X, it must have the same charge. Okay, same charge, that's why it is being repelled away from the negatively charged. So balloon X must be negative. Okay, for balloon Y, however, it is going nearer to the negatively charged balloon, so it must have unlike charges, which means it must be positive. Okay, so the answer is B. Okay, which of following should be increased to increase the current in the circuit? So we have this battery, okay, which is actually our EMF. We have current that flows through and being measured by an ammeter. We have a resistor. Okay, so formula is V equals to IR. So if I want to increase the current, okay, I must either fix V and reduce R, or again V equals IR. I want to increase the current. I can increase the voltage or the EMF while keeping R the same, right? So it's just increasing one item. So what if I increase the EMF? Yes. Okay. How about if I increase the length of the connecting wires? Now, as you know, R equals to rho L over A. If length is increased, the resistance will increase as well. So if I increase the resistance, then by V equals to IR. If my resistance increase, my V keeps the same, my current will decrease. So therefore, it is not correct. If I increase the resistance of the resistor, definitely no. If I increase the temperature of the resistor, I think I've mentioned that as temperature increase, resistance will increase. Okay, temperature increase will bring about a increase in resistance of the resistor. So again, this is no. So the answer is A. Now, what's the unit of electromotive force? It is volts. Okay, so joules is the unit for energy. Ampere is the unit for current. So this is our A, this is our I, this is J, energy is W or E. Then watt is the unit for power. Okay, power is P, watt is W. So answer is B. A student sets out a circuit as shown, a charge of 4.9 coulomb. So this is my Q, because it's charged, flows through the resistor in 0.7 seconds. So this is the time. What is the current through the resistor? Which direction do the electrons flow through? And what is the direction of the conventional current? Okay, we can actually do the conventional current first. So conventional current always comes out from positive and enters the negative. Okay, on the other hand, electrons being negative will come out from the negative terminal and goes into the positive terminal. So with that, direction of electron flow, take note that it is through the resistor. So if the electrons flow this way, it is going from left to right. So this is the correct answer. And if we now look at our conventional current flow through the resistor, right, it will be from right to left. So the direction of electron flow is opposite to the direction of conventional current. Okay, so it's right to left. Okay, yeah, so now we need to calculate current. So what is the formula to use here? Q equals to IT. Q is 4.9, I is the one that we want to find, and T is 0.7. So take note, the T must be in SI units. Sometimes the question can give you in minutes. Okay, so 4.9 divided by 0.7, it will be 7 ampere. Okay, so answer will be A. Okay, let's move on. Question 5. A student has 4 copper wire of different dimension. Which of the wire has the largest resistance? So this is R, right? So we are looking at R equals to rho L over A. Okay, so we have our length over here, but over here we are given diameter. So where is our area, cross-sectional area? Do take note that area equals to pi R square, or pi, if I want to put it in diameter, it is d over 2, because radius, it is d over 2, and don't forget the square. Okay, so if I want largest resistance, I want resistance to be very high, and because they are all copper wire, they will all have the same resistivity. Okay, and resistivity, it is this rho symbol. So all their resistivity will be the same. So I'll need to look out for large or long L and small area, right? If you look at the formula and if you apply the math, if my length is high, my area is small, my resistance will then be large. Okay, so I will be choosing this 300 and 100. Okay, because if you look at the diameter, it doesn't differ by a lot, but maybe we should calculate what is the resistance for A and B and C and D. Okay, so RA equals to rho. I'm going to keep rho as a constant here. Length is 300. It's okay. Because I'm going to compare all, so I won't bother about the cm and the mm, because they are all having the same mm and they are all having the same length units, which is in cm. So the area will be pi. For A, it is 0.1 divided by 2 square. Okay, I'm just going to do everything together, then later I'll press the calculator at one go. Okay, so this is 0.2 over 2 square. Okay, I'm using the diameter. For P, divide by 2 to get the radius, and I square it. So RC, rho 300 pi 0.4 square, and RD equals to rho 300. Oh, sorry, it's not 300. So the length for B is 100. The length for C and D, it is 50, and this is 30 pi 0.5 whole thing square. Okay. Actually, we don't really need to work it out, because I see that the length for A is the largest, and the diameter, which means the area, will be the smallest. Because the diameter is the smallest, therefore the area will be the smallest. So this is what I want from here. Therefore answer is A. Okay. Now a resistor with resistance R is made of length of wire with a cross-sectional area of A. A second resistor with resistance 3R is made from wire of the same material. That means the resistivity is the same. Okay, with a cross-sectional area of 0.5 ampere. What is the length of wire of the second resistor? So I'm going to call the first resistor, okay, number 1. Okay, so it has a resistance of R. This is the length. This is belonging to number 1, and this is belonging to wire 1, and of course the resistivity is the same. Now for the second wire, the resistance is 3R. Same material, therefore it has the same resistivity. Cross-sectional area of 0.5 A. Okay, so this is a classic case of whereby we have two scenarios, two cases, and we always look for the thing that is the same among them, so we can do a comparison and form into an equation. So can I say that resistivity 1 equals to resistivity 2, right? Because they are of the same material, and because the formula is R equals to rho L over A, I'm going to make resistivity the subject of the formula. So R over A, R times A, because my A bring over, divided by L, because my L is on the numerator, I bring over, becomes the denominator, is equals to resistivity. So I will have R1 A1 over L1 equals to R2 A2 over L2. Okay, so this becomes a very neat equation, and I take note that resistance of the first wire is R, so I'm going to replace R1 with R. A1 is A, L1 is L. Okay, for resistor 2, it is 3R, right? 3R. The area, cross-sectional area, is half A, and I'm supposed to find the length of the second wire. Okay, so I see that R and R are on the numerator. They can both be cancelled. A and A can be cancelled, right? So what I'm left with on the left hand side is 1 over L equals to 3 divided by 2 from here, and L2. Now L2 is, I do my cross multiplication. L2 is the length of the second wire. So L2 equals to 3 over 2 L. Therefore, answer is 1.5 L. Alright. So this is a very useful method when we have two cases whereby they have a common variable. They have a common factor. Okay, I think we can also apply this to question 7. A copper wire has a resistance of 2 ohm. So this is, maybe I call this R1. Okay, I call this R1. A second copper wire is twice as long as the first wire. So if the first wire is L1, okay, the second wire L2, the length is equals to 2L1, because from the description it is twice as long. So the second wire's length, it is twice the length of the first wire. Okay, take note, the diameter is twice the diameter of the first wire. So can I say that D2 equals to 2D1? Okay, so they want us to find the resistance of the second wire, which is R2. Okay, and again, both are copper, therefore their resistivity 1 is equals to resistivity 2. Same thing, RA over L equals to resistivity, so I have R1 A1 over L1 equals to R2 A2 over L2. Okay, so R1 has a value of 2. How about A1? A1, what's the formula for area? Area cross-sectional is pi D over 2 square, right? Or the more familiar one is pi R square. But you know that D over 2 is equals to your R. Okay, so I can do my A1, which is, I need to put in my pi D1 over 2 square over length 1, it is L1. Okay, R2 is the unknown. A2 will be pi D2 over 2 whole thing square over L2. Okay, but from the passage, from the question, we know that R2 pi D2, it is twice D1. So I'm going to put 2D1 into the formula, right? I'm replacing my D2 with 2D1. And don't forget, I have a 2 below and I have a square. How about for L2? L2 is actually 2 of L1, twice the length of L1, so I get 2L1. Okay, which means to say this is equal to this. Okay, so I make everything into D1 and L1. Okay, and I see that L1 and L1 are both in the denominator, so I can cancel them. The pi and pi I can cancel. Okay, but what is more difficult is this. I will have 2 O times D1 square over 4, right? I apply the square into the bracket. I will have D1 square over 4. And because L1 is gone, so it will just be equal to R2 So now I need to apply the square inside. So I will have 4d1 square, right? Square 2. 2 is squared and d1 is squared. And my 2 and at the bottom will also be squared. Okay, so in fact, if you are fast enough, you can cancel the 2. So that is what I'll be doing. I'll be cancelling the 4 and 4. But please take note, there is still a 2 at the bottom. Okay, so I rearrange everything. I simplify everything. So I have d1 square and over 2 equals to r2 d1 square and over 2. So again, 2 and 2 are in the denominator, so I can cancel. d1 square and d1 square are both here. That means r2 equals to 1 ohm, right? So eventually everything cancels out and r2 equals to 1, which is 1 ohm. Okay, so this one may be a little bit tough, right? Because there's a lot of manipulation. So if you want, you can also sub in diameter. For the first one, let's say d1, you can let it be 1, just a value of 1. Okay, so therefore d2 will be 2 because it's twice the diameter of d1, twice the diameter of the first wire. Okay, so sometimes you can use numbers. Okay, the structured question, question 1, it shows an electric circuit in which a direct current is flowing. Calculate the total charge. Now, what is charge? Charge is having a value of Q, not value of Q, symbol of Q. It passes through a point B in the wire when a steady current of 1.5 ampere. So this is my I. Through it for 10 minutes, so this is my T. But just now I already told you all need to convert it into seconds. So T is 600 seconds. Okay, and the formula is Q equals to IT. Substitute in with the correct units, you get 900 coulomb. Now, if the charge on each electron is this value, 1.6 times 10 to the power minus 19 coulombs, which is very, very small, calculate the number of electrons that pass through the point in the same duration. So you are going to use this total charge. Sorry, it's not 600. It is 900. 900. Oh, no. The time is 600, but the final answer is 900. Okay, so that's the total charge that we are going to substitute in. And within this 900 coulombs, how many electrons are actually there? If each electron has 1.6 times 10 to the power minus 19 coulomb. So the answer is this. That means I will have this number of electrons. And with this number of electrons, of having such a small charge, then I can accumulate to become 900 coulombs. You can think of it that way. Now, show on the diagram the direction in which the electrons flow past the point B. Okay, so you should know that the longer side is positive, the shorter side is negative. And electrons come out from negative terminal, right? So this is the direction that the electrons can flow through. Okay, question 2, the EMF of a cell is 1.5 volts. Now, what is the energy supplied by the cell in driving 0.3 coulomb of charge? This is my Q around a circuit. So we have this formula. EMF equals to work done over charge, or EMF equals to energy over charge. So if you can identify all this, they are asking us to find the energy, which is W. You can then get your answer of 0.450 joules. Now, if a potential difference of 240 volts, so this is my V, or the potential difference, PD, applied across an electric heater causes 4 times 10 to the power of 3 coulomb of charge. So this is my Q. To flow through the heater coil, calculate the amount of electrical energy converted to heat. So this is either W or E. Now you already know this formula, W equals to VQ, which is somewhere over here. You should get this value of energy. Okay, electric eel delivers electric shock to stun its victim. The ability is due to special cells. These are called electrocytes. They are able to produce an EMF of approximately 0.15 volts each. Okay, so if I have 2 or 3 and they are connected in series, I can add them up. But the eel possesses 5,000 to 15,000 arranged in series. So it can add them up. Okay, electric eel needs to be in contact with the victim for an average period of 5 millisecond. Don't forget milli has the value of 10 to the power minus 3. In order to stun it, if a current of 7.5 ampere, I call this I, determine the amount of charge, this is Q, that will pass through the victim in 5 milliseconds. So actually I have my time, I have my current, I can find my charge. So Q equals to IT, don't forget the milli, you should get 0.0375 coulombs. Now a person in water got an electric shock from an adult electric eel. The adult eel applies a PD of 2200, so this is my V, across the skin for 5 milliseconds. So same thing, same amount of time. Okay, assume that the resistance of the human skin is 2000 ohm when wet. So this is R. Determine the minimum number of electrocytes that the adult eel had. Okay, so it was said that the adult eel applied a PD of 2200 volts. Okay, and each of it has 0.15 volt each. Therefore, there is this number of electrocytes, assuming that all are working. Okay, now what's the electric current that passed through the person's skin? So this you have to actually interpret from the question using V equals to IR. Okay, the V is actually the 2200. The current is the one that we are asked to find, and we are also given the resistance of 2000, so you'll get 1.10 ampere. Okay, part 3, continue. The energy, which is E or W, used by the eel to shock the person. So we can use Q equals to IT, because we have to find the amount of charge, and basically then we can use the Q with the correct V, we can find the work done. Okay, because don't forget the formula is V equals to W over Q. Therefore, to find W, we need to multiply V and Q together. But because we don't have the Q, we have to use Q equals to IT, right? Use the current from before, and the time being 5 milliseconds, we can get 12.1 joules. Now, explain how it is possible for the electric eel to produce a PD of 2200 volts when each one is only capable of producing 0.15 volts because they are connected in series, and in series, the EMF can be added up. Okay, copper wire of length 1.5 meters and diameter, okay, has a resistance of 2 ohm. Determine the resistance of copper wire of length 2.5 meter and diameter 1.2 times 10 to the power minus 4. So now this is another copper wire. So again, this is our two case scenario. Okay, so we do not know the resistivity. So over here, the solution calculates the resistivity. But let us try to use the two cases formula, because rho 1 equals to rho 2. So this is L1, D1, and R1. Okay, they want us to find the resistance of another copper wire. This is L2, the length 2.5 meters, and this is D2. Okay, so R equals to rho L over A. Therefore, rho equals to RA over L. Just manipulate, okay, and you will get this. You can try practice manipulation. Okay, so can I say R1 A1 over L1 equals to R2 A2 over L2. So R1 is actually 2, A1 is actually pi 1.2 times 10 to the power minus 4 divided by 2, and this thing is squared over length. Length is 1.5. Okay, and on the other hand, the R2 is unknown. I'm asked to find pi. The diameter is 1.2 times 10 to the power minus 4. So we find that actually the diameter is the same. So why not I just cancel them? Okay, over the length is 2.5. Okay, so you see, once I cancel this, I am left with 2 over here divided by 1.5 equals to R2 over 2.5. So rearranging, make R2 the subject of the formula. 2 times 2.5 bring over 1.5. So I should be able to get 3.33. Okay. Okay, so you can always try to use these two cases. Okay, question 5 is a VI graph. Okay, it shows A and B at a steady temperature. That means the temperature remains constant. That means the resistance, okay, will not be affected by the temperature, so it's going to be constant. Now determine the resistance of A and B using V equals to IR, and if I make R the subject of the formula, I bring V over, it becomes V over I. That means I can get the changes in V over the changes in I, and therefore I can get my resistance. So I can do it for RA, resistance of A and resistance of B. Okay, I can use 2 over 0.6 and 3 over 0.2. Okay, so both the conductors are made of the same material and have the same length. State which conductor is thicker. That means the cross-sectional area is larger. Explain your answer. Okay, so the answer must be B because the resistance of a wire is inversely proportional. So if I look at the formula, R equals to rho LA. Remember, you can actually use this formula to explain, right? R equals to rho L over A. Okay, so if I have a larger R, that means my A must be smaller. Okay, sorry. Actually, they're asking for which one is thicker. That means the A is high, and if they have the same length, they have the same resistivity, a larger cross-sectional area will bring about a smaller resistance. And if you compare, resistance of B is smaller than resistance of A, so that means B will have a thicker wire because it has a smaller resistance. Now calculate the ratio of the cross-sectional area of wire A to that of wire B. Okay, so again, this is the two cases formula, two cases solution. So they want us to find the ratio of A to that of B. Okay, so it is AA over AB. And what is it? Okay, now R equals to rho L over A. Because they have the same length, I don't need to consider the length. Because they have the same resistivity, I don't need to consider the resistivity. Okay, so can I say that R times A equals to 1, right? Because I don't need to care about them. I just bring this over, RA equals to 1. Okay, or should I say that then for RB, the second resistor, I will also have RA equals to 1. That means I can form a, because they are both the same, right? So can I say that RAAA over is equals to RBAB? Okay, so if I want AA over AB, I'll leave AA here. I bring AB over. It will then be equals to RB. I bring RA over. It becomes RA. So that's why I form this equation. AA over AB equals to RB over RA. And because I have RB value of 3.33 over RA value of 15, I get 0.222. So some of you may be wondering, how come I don't express it in the value of this is to this, like in your math? Okay, so in O-level physics, they always go for 3SF, even if they're asking for ratio. Okay. Okay, question 6, it shows in the diagram voltmeter and ammeter. Initially, a resistor is connected between point A and B as shown. So this is the resistor, and we also have a variable resistor. On the diagram, show how the voltmeter and ammeter should be connected to enable the resistance of the resistor. So we have two resistors. They are talking about a fixed resistor. So voltmeter must always be connected in parallel. Okay, and ammeter must be in series. Okay, by the way, this will be the positive terminal of the ammeter, and this will be the negative terminal of the ammeter. Why? Because the positive must be connected to positive, negative connected to negative. For the voltmeter, here will be positive and here will be negative. Why? Positive to be connected to positive, negative connected to the negative. Okay, so explain why the ammeter and voltmeter is connected differently. Okay, ammeter is connected in series. okay, because it has zero resistance. This one you need to take note, okay, virtually zero resistance or is negligible. Voltmeter is connected in parallel because it has very high resistance, okay, so we don't want the current to flow through the voltmeter, right?